Let's take a look at conditional statements. Remember that in mathematics, statements are either true or false with nothing in between. And when we're talking about conditional statements, we're talking about two smaller statements like P and Q that we are combining to make an overall statement that will be either true or false. And conditional statements are essentially anything that can be written in an if P then Q format, where the hypothesis will be the if portion and the conclusion will be the then portion. So let's take a look at this. We actually have conditional statements all over in life. We say if something happens, then there will be a conclusion or a result. So if someone is saved, we say then they will spend an eternity in heaven. It is the conclusion that we are making. Here would be our if portion, the hypothesis P, and here would be our Q portion, the conclusion Q. So these will pop up all over the place in real life, but keep in mind that they won't always be in an if-then format. For instance, every square is a rectangle is a conditional statement. What it's really saying is if you have a square, then you have a rectangle. And again, you can see this, we're starting with one assumption, we're moving towards this other conclusion. And because of that, it falls into the if P then Q. And they'll sometimes even reverse it in the English language. So school will be canceled when a quarter of you are sick. Well, the if portion, or the hypothesis, is actually what happens first. If a quarter of you are sick, our P portion, then school will be canceled, so Q. So that is, in essence, what a conditional is. If something happens, then there's a result. And you can already see I'm kind of like leading into the notation that we're going to be using. The notation for conditional statements is actually that P implies Q. And for implies, they're going to draw an arrow, which really matches what's happening. They're saying start at P, it should move you to Q. And if it doesn't, there's going to be a problem. So let's take a look next at when those problems occur. Let's start with the original conditional. If you all get an A on the next quiz, then I will throw you a pizza party. And you guys have to determine whether or not I've told the truth depending on what's happening with P and Q. So let's start with this. Let's say all of you guys got an A on the next quiz. In this case, we know that our P is true. And in the end, I threw you a pizza party, which would be Q is true. Well, I wouldn't be lying to you. I told you if you got an A, then you get a pizza party, and that is true. So that means when both are true, overall statement is true. Now, let's say we had this happen. All of you guys got an A on the quiz. Excellent, awesome, I would be thrilled. But I didn't throw you a pizza party. Whoop. At this point, I have directly lied to you. Since I told you that it would result in a pizza party, and I didn't give you one, that right there would be a lie, leaving us with a false statement. And again, we're watching out for those because those are often going to be really key in mathematics. Those are going to be our counterexamples, the instances that don't work. Let's check out the weird ones though, because these often throw people off. Let's say some of you didn't get an A on a quiz, which is completely reasonable. But I decided to throw you a pizza party anyway. In this case, weirdly enough, I haven't yet lied to you. It isn't a falsehood to throw you a pizza party anyway, and it doesn't mean that I would have lied about you getting an A on the next quiz. I just decided to do it anyway. So believe it or not, if the first thing doesn't happen, it's still considered true. So anytime the hypothesis is false, it really won't matter what I do afterwards because I can't mislead you because we never actually started. The same thing happens down here. If some of you didn't get an A on the quiz and I didn't throw you a pizza party, I'm still not a liar because, again, we never met this first requirement. So you can't even say that I didn't go to the second one because, well, we just don't know. And so that's how it's going to end up working in geometry. The only way in which you will be able to prove something wrong with a conditional statement is if the hypothesis is true And the conclusion, the second part, is false. Again, we call this a counterexample. The if portion must be true, the then portion must be false.